All right. Okay, coming back for part 2 here. The worksheet 12.1, part 2. So this deals with unit vectors. Now, don't worry too much about this. It's actually stuff you've actually been doing. You've heard of unit circle. Well, it's the same thing, except the unit circle deals with just unique values, like 30, 60, like 36 degrees, 90 degrees, just unique vectors. But basically, on the unit circle, it deals with the radius of 1. So basically, taking a vector and reducing it. So let's take a look at some of the ones that we already have. So in a unit circle, so again, unit circle of r equals 1, we have, like say this vector out here at 30 degrees, and that vector was root 3 over 2 comma 1 half. Okay? If we did, let's say 60 degrees, that vector then was 1 half comma root 3 over 2. So basically, if you look at, instead of an ordered pair, at them as a vector, that if I multiply, let's say something like this by 2, a scalar, I've extended then this vector out to root 3 comma 1. Now I could also multiply that by, let's say, another scalar. Let's say multiply that by 2. Which means I'm multiplying this one by 4, therefore now it's 2 root 3 comma 2. So basically a unit vector is taking this length, and let's just do this one first. So if I have a vector of root 3 comma 1, is to reduce it down to a value of 1. So what you got to do here is you got to find the magnitude. So how do you find the magnitude? Pythagorean theorem. So you have, in this case, c squared equals a squared plus b squared. In this case, we're going to say d squared. So we have 3 plus 1. So d would be 2. And what you do is you just divide the distance in with here. So you take root 3 comma 1 and divide it by 2. Therefore what you have is root 3 over 2 and 1 half. And therefore you have a unit vector. Now obviously we got to use some notation here for this. So unfortunately they're going to use E again. That's more like a printed E. And if this is some kind of vector, let's say this is vector v, then they just put the v down here. So therefore the unit vector of this would be root 3 over 2 and 1 half. Okay. Just to show that this works, let's come up here and grab the next one here. Change it in color. So let's say we have 2 root 3 comma 2. Okay, so we have that vector. So d squared would be 4 times 3 plus 4. Okay, this would be 12 plus 4 for 16. So now I'm up here, my unit vector, and let's call this a vector m. So my unit vector of m would be taking 2 root 3 comma 2 and divide it by 16. Okay, so oops, actually that would be 4. I forgot that was d squared. So actually that would be 4. So what I have now is root 3 over 2 and 1 half. Okay. And that's what a unit vector is. Also, too, another notation, I just thought of it. They might just say a unit vector, a u. Okay, But this is more specific because it tells me which vector you're dealing with, m. Okay, and that's basically it. So if we look at some of the things you've actually been doing on unit vectors, for example, if you use these equations, like say the x component of r cosine of theta, this here you're taking is the unit vector. And so therefore, and this is the magnitude, which would be the scalar. Okay. So if you have, let's do 30 degrees again. Let's say theta is 30 degrees. But here's your vector. So my components is root 3 over 2, 1/2. So we're just looking at one component, let's say your x component. So if I take root 3 over 2 and say I'm going to multiply it by 4, well, that's your magnitude. So if your magnitude is 4, you 4 times that would be 2 root 3. And that's all you're doing. So you've been taking, like I said, this piece is the unit vector part, and this is the scalar. And then if you do one for the y vector, y component be r sine theta. So again, here's your unit vector. And here's your magnitude. And that's basically it. So if you want to look at, how do you, well, let's just do some here. So let's say, here's my question. Say, find the unit vector, and say E of V, where vector V is 7 and 24. Okay, so if we graph this out so you can kind of get a visual of this. So let's say 7, and this is say up here is 24. Here's your vector 7, 24. Okay, vector V. So what I want to do here is basically I want to shrink it down. So here I want to shrink it down. So unit vector, so therefore this piece is r equals going to be 1. So how do you shrink it? Well, you got to find the distance. So d squared equals 7 squared plus 24 squared. And I think this is 7, 24, 25. So my distance is 25. So this distance is 25 units, which is the magnitude. Well, if I just take that and divide it by 25, therefore my unit vector would be 7 over 25 times 24 over 25. And now you got a new value, so now you can actually refer to this as on the unit circle. Oops. So you got another unit circle value. Okay. Now sometimes, just to avoid fractions, sometimes you might see me do this, like 1 over 25 and then 7 and 24. And I just leave the magnitude out here just so I don't have to deal with two fractions. I just have the 1. Okay. Let's reword this a little bit. So let's say find a vector of length 12 units in the direction of, and I'll say unit, I'll say U, probably bad notation, and -6, 8. Okay, so let's graph it out so you can visualize this. So here's -6, here's 8. So right now, here's the vector. So if you look at what the magnitude or the distance now, this is a 6, 8, 10, so the distance is 10 units. Okay, I want to find the vector out here. That is, so my distance is 12 units. What would be my components of that? Well, so what you got to do here is you got to find the unit vector. So it's e to u. Okay, so what I got to do is I got to shrink this down to a unit vector. So therefore, since my distance is 12, or 10, excuse me, divide that. So my unit vector is -6/10, 8/10, and reducing that, I get 2 out, -3/5, 4/5. Okay, there's my unit vector. Well then, if I want to say what's my vector of 12 units, well, multiply by whatever scalar you want. So let's multiply by 12. And therefore, now my new vector here, and we'll call it, let's say, vector m, would be -36/5 and 48/5 is now my new vector with a magnitude of 12 units. So therefore, what's the distance? The distance is 12. And if you want to check, you can go through and check it if you want. Let's change up the question again here. So let's say find a vector with a length of 6 units with the angle of pi/3, and this is with the x-axis. Okay, all right, so let's get an idea. So remember, that's the same thing as 60 degrees. So drawing this out, 60 degrees, I got a vector here at pi/3, or 60 degrees, and this distance is 6 units. So what do I got to do here? Well, first off, you got to find the unit vector. Well, we know, since this, that if we come back here, my unit vector, and we'll call it, say m, would be 1/2 √3/2. So therefore, all you have to do is multiply it by your magnitude, 6. And therefore, what you have now, your vector here. So this value here, your new components would be 3, 3√3. Now you could also do it by, there you have r cosine theta, and y equals r sine theta. Because again, remember, here's your unit vector, and here's your magnitude. Okay, so you just multiply, which is the same thing I did here. Okay, so this is the same as this. Okay. All right. Let's take another way of answering this, or asking questions. Okay. So let's say we have 2 points. Okay. And my 2 points we'll call R of 4, 7. And my other point is negative 3, 6. Okay, so first off, let's find a vector in standard form. So we'll say RP. So we gotta go negative 3 minus 4, 6 minus 7. You have negative 7, negative 1. Okay, now, so that is, let's draw this out for a visual. So we have negative 7, negative 1. Here's my vector here going in that direction. So this is vector RP. Okay. All right, so I want to find the unit vector of this. Okay. So what's my unit vector? Let's keep it simple here. Let's come up here and give this, let's say t. So this is going to be e of t. So what's my magnitude of this? Well, d squared equals 7 squared plus 1 squared. So we got 49, 50. So d would be 5 root 2. So take 1 over 5 root 2 and multiply by negative 7, negative 1. And there's my unit vector. So now I have a new value on my unit circle. Okay, so this is now on the unit circle, but we just call it a unit vector. Okay, what's the next thing here? Let's do something, let's change it up here, something other than just a unit vector. Let's say find the point M such that Rm has a component of 5, 9. Okay, now this is with regards to the point above here that R was 4, 7. So we're finding a new value. So if we're looking for, say, Rm, that would be a value. It would be like, say, x minus 4, y minus 7. And that would equal, let's say, 5, 9. Okay. So that would mean then, looking at individual components, we have x minus 4 equals 5, y minus 7 equals 9, x equals 9, y is 16. Therefore, my point M would be 9, 16. Okay. And therefore, if you want to check it, let's say if you want to find the vector Rm, that would be, like, say, 9 minus 4, 16 minus 7, and we have 5 and 9. Okay, so there must be a question like that on your assignment. So anyway, hopefully you're wrapping your head around what a unit vector is. Okay, you've been doing them, which is a good thing. Just understanding what they are, and we'll add a lot more to this. Like I said, unit vectors are a powerful tool, and I'll explain more and more in detail of what we're going to be doing with these things and all that. A lot of this stuff comes all the way back to Algebra 2 that you've been doing, and trig and things like that. Just wrapping your head around stuff, the mathematical part you've done, just understanding what this is.